All right, here we go. We're going to be talking about periodic phenomena. Basically, we're talking about motion and patterns. So we're going to our trigonometry unit, and trig is about periodic motion and patterns, things that repeat itself, right? Over a certain period of time. So you have two sets of notes. You have notes and assignments. They eerily look the same. So look and make sure that you're on the one that says notes at the top and not the one that says assignment at the top. Okay. So just wanted to preface that first. Okay. So, what is a periodic relationship? So, a periodic relationship is between two variables and occurs when the output values demonstrate a repeating pattern. Okay. There's going to be a pattern. Unlike when we have exponential, it's not, or linear, it's not an additive pattern like you're adding the same amount or multiplying by the same amount. It's a little more in depth, but they're going to be equally linked apart, and your job is to figure out that pattern. The period is how long does it take for that pattern to repeat? Does that make sense? So the period is how long is it going to take for that pattern to repeat, for that cycle to occur again. Okay. So let's start off with a non-trig view of phenomena, of periodic phenomena. So as you can see here, we have this function. This is a function because my vertical line test is successful, right? Well, in AP Pre-Cal, you cannot say that this is a function because it passes the vertical line test. And AP, you would say that for our input, there are no repeating values or something, but you have to define, and they will not give you credit if you say it's a function because it passes the vertical line test. We cannot say that in AP Pre-Cal. Got it? But it's a function because there are no repeating input values, right? My x values do not repeat. So this is a function, and the period is for long, meaning that here's a pattern, and it takes 4 units for that pattern to occur. Do we see that? So it's an increase, a constant, then a decrease. And it took 1, 2, 3, 4 units of measurement for that pattern to happen again. That's why it's called my period. Agree? Okay. A portion of the graph is drawn. Knowing that, could you draw 2 additional periods based on what you see? And the answer should be yes. So when we're drawing, you want to pay attention to key factors here. This is linear, and this is a linear piece with a slope of 1. Agree? Up 1 over 1. Yes? We have a constant piece here with a slope of 0. And then we have another linear piece here with a slope of, -2, not -1. There we go. Yes? So when I start this, I'm going to follow exactly what I said. From here, I need a slope of 1. So I'm going to go up 1 and over 1, up 1, over 1. Boom. And remember, pretend that these are straight lines. Yep, they're touching. They're friends. All right, and then I have a slope of 0, a constant. And then I have a slope of -2, so I go down 2 and over 1. Boom. That is 1 cycle. And it wanted me to add on how many? 2. So I'm going to repeat again. I'm going to have a slope of 1, up 1, over 1, up 1, over 1. A constant. And then, yep. These are all the straightest lines you've ever seen. But that's the gist for us to get used to the vocabulary, okay? The period is the length of time that it takes us, right? The cycle is 1 pattern of the repeat, okay? So I created 2 cycles in total. How many cycles are there? There are 4 cycles of this periodic motion. Yes? All right. Let's look here. So it says a portion of the graph of the periodic function g is shown above or below here. What is the least possible value of the periodic of g? So when we're looking here, we're trying to figure out what is the pattern that is being repeated. There's a couple that we see, right? And it's saying what would be the least possible value of the period of g, meaning what is the shortest length of time that a pattern could take place. So how many different patterns do you see, or how many things do you see that could create it? You could start at -2 and end at 3. I agree. I see that. -1 to 4. I see that as well. Do we see where they're getting those at? Your options? Okay. If not, let's talk about where are these options. So as we said, we could start at -2 and end at 3. And then that pattern would continue again, right? There you go. Zoop, 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 boom. Yes. And if I chose that, what would be the length of that period? What would be my length of my period would be 5 units. Yes? Agreed? Okay. Eleanor said we could start at -2, -1, sorry, and we can end at 4. Does that also work? And what is the length of that? So what will be our shortest possible value of our period? 5. Yes. Was that terrible going backwards? Okay. The next thing is being able to evaluate from a using cycle, period and cycle. So if I'm evaluating here, here's function G. Should I easily be able to do it? If I see it, yes. But what do you notice? Is 14, 72, or 17 on here? No. That means I would have to figure out the pattern to know when these points are going to occur. Does that make sense? Okay. So it's not as straightforward. It's like, oh, G of 14 is here. Oh, but it's not. I stop at 9 and I stop at -2. So what are my options to figure out what G of 14 and G of 72 and G of -17 would be? I'm going to pause and let you figure out what you would do. And we're going to talk about it. Because I'm not going to tell you it. I need you to problem solve for a moment. Okay. All right. Okay. We established our period to equal 5. Does that make sense? So what combination of multiplying something by 5 and adding on could I get 14? Well, what about 4 plus 2 times 5? Would that give me a value? Does that make sense? Okay, so let's talk about it. So my period is 5, and I need to get to 14. Well, 5 times 2 is 10. 5 times 3 is 15, which is too much. So I need to, instead of having 4, I need to have, instead of having 5, I need a 4, which means that this would be equivalent to whatever G of 4 is. Because that's every 2 cycles, it's going to repeat because that's the period. So whatever G of 4 is, which is what? What is G of 4? 7. Every 2 cycles, I'm going to end up hitting here anyway. Yay. Let's try it again with a bigger number. Okay. So 72. Now thinking about 72, I need to think about 72 into 5, right? Because it's going to, how can I break this down using 5? So 5 times what is going to get me close to 72? 14. So 14 times 5 is going to get me to what? 70. And I need to add on how much? 2. So that means that this pattern is going to repeat starting at G of 2. And what does G of 2 give me? 6. So the answer is 6. Are y'all with me? Because it's periodic, that means that these same values, your Y values are never going to change, right? These are the limited Y values that you can have. Your job here is to figure out where is the pattern and when are these things going to keep occurring. okay? And you know that you use your period by establishing that because it has to happen every 5 units, correct? So I'm trying to get as close as possible to that number. How long is it going to take me to get there? Does that make sense? Yay, nay? Okay. Do you think it's going to be any different if I'm a negative? No, it's not. So thinking of it in terms of a negative, how can I get negative 17? A negative 3 and not a negative 3 or a positive 3? I don't have negative 3 on here. I don't know what that is. I can't use negative 3. It has to be something that is visibly. I would have to use a positive 3, and instead of adding, I am subtracting. And that would be what? How many cycles? It would be 4 cycles because 4 times 5 is 20. What is 3 minus 20? Negative 17. So therefore, this is equivalent to G of 3. And what is G of 3? 7. Okay? So again, instead of you drawing this all the way up to negative 17 or all the way out to 72, it's recognizing the pattern of how the numbers are built. Do you think this will change if we use a table? It does not. It does not change just because we use a table. Using a table is the same thing. You're going to still figure out what's the period, if it's not given, and then going from there. Okay. So let's look at our table here. It gave us our period, and our period is still what? 5. So in this case, we want to find h of negative 2. So knowing that these are our x values that we currently have, and we only can use the current x values because these are the only outputs that we know. Does that make sense? What combination of these numbers and a multiple of 5 can we get negative 2? So 1 rotation. So to get negative 2, again, you're thinking about what number can I use currently? My current number I can use is 3 is probably going to be the closest. And the being period is 1. So 1 cycle of 5. Does that make sense? So that means h of negative 2 is equivalent to h of 3. And what does h of 3 equal? 0. So the answer would be yeah. Okay, let's try it again. 6. How can I get 6? It's something plus or minus. Oh, that's not a good plus or minus here. Plus or minus something times 5. What'd you say, Piper? Perfect. 1 plus 1 times 5. So therefore, this is equivalent to h of 1, which is negative 2. All right, this is a two-stepper. We got to find h of 9 first, and then whatever its result is. So starting off with h of 9. How can I make h of 9? I heard it. Perfect. This would be h of 4 plus 1 times 5. So therefore, h of 9 is equivalent to h of 4, and h of 4 equals 3. And then it says now we're going to substitute that in. So now our final is h of 3, and h of 3 equals 0. So our final stopping point is at 0.
I know.
It's not bad. It's patterns. All right, last one that we're gonna do today. So here, now it's asking for any integer. So any integer that's taking place here. What am I doing? Well, it's just a flipper flopper here. It's already there. So for this one, notice that you already have your 5, you already have your k. It's a matter of -3 plus 5k. Because 5 is our what again? Our period. So no matter what this is, whatever k is irrelevant. It's just going to be equivalent to h of -3. And then how do I find h of -3? What combination can I use? These are only x values we have. And remember, it has to be something plus or minus a multiple of 5. Or minus 1 times 5 is not. There you go. So this is equivalent to h of 7 minus 5 times 2. Does that make sense? So the result is whatever h of 7 is. And what is h of 7? 2. Okay. All right. So we're going to finish up on this on Thursday.